Hello friends, today we will discuss in detail about the differential equation of orbit which I have introduced in my previous video. So let's start the discussion. In my previous video I have derived an equation. What's that? That for equation of motion of particle of mass m moving under central force F of r, that can be written as in which format? mr double dot minus j square, let me write clearly, minus j square divided by mr cube equals f of r. So we have got this equation that mr double dot means double differentiation of r with respect to t minus j square by mr cube equals f of r. So from here we can write, again I'm writing clearly, that differential equation we can derive easily from this equation. How we will derive the differential equation of orbit? So let's start that discussion. This is the equation we have got previous video. So now here r double dot means what? R double dot means double differentiation of r with respect to time. So we have to work on this r double dot. That means we have to work on this double derivative of this r. So before working on it, first I have to know that what will be r dot. R dot means single derivative. That means dr by dt. Dr by dt can be written as dr by d theta into d theta by dt. Dr by dt into d theta by dt, and dr by d theta into dt, d theta by dt, it can be written as dr by d theta into theta dot. Sorry. Now in my previous video I have discussed that theta dot is what? Theta dot can be derived from the first integral of motion. First integral of motion, what's that? First integral of motion is theta dot equals j by mr square, or j can be written as mr square theta dot. So from here we are getting that theta dot equals j by mr square. So putting that thing in the theta dot, we can write r dot equals dr by d theta into j by mr square. Yeah, r dot equals dr by d theta into j by mr square. So r double dot can be written as r double dot ddt of r dot. Ddt of r dot means what? Ddt of j by mr square into dr by d theta. Now this ddt can be written as d theta dd theta into d theta by dt. This terminology, this ddt can be written as in such a format, dd theta into d theta by dt. So let's try to write in such a way that r double dot equals ddt into j by mr square dr by d theta, or dd theta j by mr square dr by d theta into d theta by dt. That's right. Now again d theta by dt is coming. Again d theta by dt means what? Means we have to again put theta dot equation. Theta dot equals what we have got? J by mr square. So d theta by dt can be put here, that j by mr square again we will put. So we can write r double dot equals j by mr square, finally dd theta j by mr square of dr by d theta, right, in such format. Now we will assume a thing. We will assume a quantity, that r, in terms of 1 by u, or u can be assumed as 1 by r. So if u can be assumed as 1 by r, so du by d theta can be also assumed as, can be written as minus 1 by r square dr by d theta. So r double dot, what we have written? R double dot we have written j by mr square d theta into j by mr square into dr by d theta. Now du by d theta equals what we have got? Minus 1 by r square dr by d theta. That means this in terms of u can be written as, from that equation, it can be written as r double dot equals j square u square by m d theta into du by d theta. It's just rigorous mathematical calculation only. We are coming to the main point after the calculation, after the derivation. So we can write at last from mr double dot minus j square by mr cube, what we have written at first, equals f of r. Now if we put the value of r double dot here, we will get, so now we have got this equation mr double dot minus j square by mr cube equals f of r, and r double dot what we have got? Minus j square u square by m d2u by d theta square. R double dot we have got. Now just put this r double dot in this equation. Then what we will get? We will get the equation j square minus j square u square by m into d2u by d theta square minus j square u square by m equals f of 1 by u, f of r. R equals what we have assumed? We have assumed r equals 1 by u. So at last we are getting what? At last we are getting that j square u square, I am writing clearly. So what is the differential equation of orbit? It's very important thing. J square u square by m into d2u by d theta square plus u equals minus of f of 1 by u. It is the differential equation of orbit. So it is very important. There is a differential equation of orbit under central force law. It's very much important. Why? Because from this equation, from this differential equation, we can derive Kepler's first law. So let's start, up to which we can discuss. So we have got what? We have got f of 1 by u. So if it is given to me such that f of r equals minus k by r square, that means what? Inverse square law. If it is given to me that inverse square law is given, inverse square law force, inverse square law force is given to me, then what, how we can proceed with the differential equation of orbit? So let's start discussion about that. If it's given to me that f of 1 by u equals minus k u square, then we can write how? We can write d2u by d theta square plus u, the differential equation of orbit, and that equals minus equals minus of m of j square by u square, minus and minus, that will be plus j square by u square, and because here minus k u square is here, so f of 1 by u, that is k u square. So first we have to write differential equation of orbit again. So we can write differential equation of orbit firstly in the format of a differential equation, that d2u by d theta square equals d2u by d theta square plus u equals minus of m by j square by u square f of 1 by u. This was the differential equation of orbit. Now if the condition is such that f of r equals k by r square, k by r square, k by k divided by r square, this inverse square law of force is given to us, then how we can proceed? Then in which way we can proceed? So we can proceed in such a way that f of 1 by u equals f of r equals minus k by r square, r equals 1 by u if we put r equals 1 by u if we put, so we can write f of 1 by u in such a way that minus k by r square, so 1 by r square u square minus k u square. We can write f of 1 by u minus k u square. Now we can, if we put the differential in the differential equation of orbit, this force field, what we will get? d2u by d theta square plus u equals m by j square u square into k u square. So we are getting a term. So I'm first simplifying it. d2u by d theta square, here u square will be cancelled out, so we can write d2u by d theta square plus u minus mk by j square equals 0. Yeah, so we are getting this much equation, d2u by d theta square plus u minus mk by j square equals 0. So we are writing the equation again, d2u by d theta square plus u minus mk by j square equals 0. Now if we put this u minus mk by j square equals x, so what we will get? This equation will be turned into the form, if we put these terms x, d2x by d theta square plus x equals 0. So solution of this equation will be x equals some constant c into cos theta minus, I'm taking it c prime, theta minus theta prime. These will be the solution of the equation. I'm writing clearly. So solution of the equation will be x equals c prime cos theta minus theta prime. That is the solution. Here c prime and theta prime both are, wait, let me write, constant of integration. Constant of integration. So here c prime and theta prime both are constant of integration. So we can write what? So we can write, we have put what? X equals u minus mk by j square, and x equals what solution we have got? C prime cos of theta minus theta prime. So we can just equate these things, because x equals we have got this and x equals we have got this. So we can easily equate these things. If we equate these things, 1 by r minus mk by j square equals c prime cos theta minus theta prime. So if we put this left hand side here, 1 by r equals mk by j square plus c prime cos of theta minus theta prime. So now if we equate this, 1 by r equals mk by j square plus c prime cos of theta minus theta prime. Now if we multiply both side by j square by mk, so we will get an equation, and what is that? So we get the equation j square by mk divided by r plus 1 by 1 plus j square c prime mk cos of theta minus theta prime. Yeah. Now it is a form. I'm telling you after some time what is the importance of it. So it can be assumed as L, and this j square c prime by mk if we assumed as E. So it can be written as this form: L by R equals 1 plus E into cos theta minus theta prime. So L equals j square by mk and E equals j square c prime by, let me write, L equals, where we will get L equals, let me write clearly, L equals j square divided by mk and E equals j square c prime by mk. So what we are getting? We are getting L by R equals 1 plus E cos of theta minus theta prime. So we are getting this equation. Now it is very much easy to identify that E can be written as another form. Now there is a rigorous calculation from where from the first integral of motion theta dot equals j by m r square. I am not going to show you because you will be bored in seeing that calculation, that E can be written as root over 1 plus 2 E j square by mk square. That this E, whatever we have got here, E can be written as root over, from the first integral of motion, 1 plus 2E j square by mk square. So we are getting the differential equation L by R equals 1 plus E cos of theta minus theta prime from the first integral of motion, where E is given by root over 1 plus 2 j square by mk square. It is very much important things here. Why it is important things? So before going to discuss that things, I will now discuss why it is so important. First, I will discuss what is the Kepler's first law of planetary motion. So Kepler's law of elliptical orbits tells us that every planet moves in an elliptical orbit around the sun, and sun is situated where? Keeping the sun at one of their foci. Foci means at one of their focus, any of their foci. So from that, then what is the importance of this equation? V equals 1 plus 2 square by mk square. From where we are getting? We are getting that from differential equation of orbit, we are getting an equation 1 plus e cos of theta minus theta prime. There E equals, we have got j square c prime by mk. Now from rigorous calculation we can show, here I am not going to show that calculation, it is very much a rigorous calculation, that E can be written as 1 plus root over 1 plus 2e j square by mk square. So from this equation, this E decides what? The nature of the orbit. Why? Now E value, I am going to make a table here. E, and capital E is what here? Capital E is here total energy. J is, you know that j square equals m r square theta dot, and K is some constant here. So we can write something here. Conic section. We can discuss the nature of the orbit here. So if E is greater than 1, then energy total energy E will be greater than 0, then the conic will be hyperbola. Again I am going to tell another thing. If E equals 1, then the total energy will be E equals 0 and the conic will be parabola. I am showing an example here because E equals what? E equals 1 plus 2E j square by mk square. Now E equals what? E equals 1 means root over 1 plus 2E j square by mk square. Now squaring on both sides, what you will get? Squaring on both sides, you will get capital E equals 0. That means E equals 1 is giving capital E equals 0 and the conic is parabola. Another important thing that's important here, if E is less than 1, then energy will be less than 0 and the conic will be, that means orbital will be ellipse. And one of the most important things, if E is 0, then what will be happened? E is 0, then energy will be minus mk square by 2j square and the conic will be circle. So what we are getting? We are writing one by one. E greater than 1, then E greater than 0, then hyperbola. E less than 1, that means E less than 0, that means ellipse. E equals 1, that means capital E, energy equals 0, it is greater than. So E equals 0, that means what? That means it is parabola. And small e equals 0, then capital E energies will be what? Minus mk square by 2j square, that is circle. So by this way, from the Kepler's first law, what we have got, that every planet moves in an elliptical orbit around the sun, and sun will be what? Sun will be at their foci. Sun is at their foci. So from this equation, we can determine the nature from which equation. So from the equation E equals root over 1 plus 2ej square by mk square, we can determine the nature of the orbit in this way. So that is the things today's in our discussion. So that's it for today. Thanks for watching and keep patience. In our next video, I will discuss Kepler's other law. Thank you.